All right, this is Algebra 1B Part 1, Unit 4, Lesson 5. We're going to solve inequalities. Now, let me define a couple of things. An inequality, in meaning not equality, is any class of algebraic sentences or expressions in which we use something other than just an equal sign, a less than, a greater than, a less than or equal to, a greater than or equal to, or even a not equal to. Okay. By the way, if you're typing on a keyboard, a less than is a less than, a greater than is a greater than, a less than or equal to is a less than followed by an equals, a greater than or equal is like greater than followed by an equals, and a not equal to is a less than followed by a greater than. So be aware of those keyboard shortcuts that you can use when answering essay questions. Inequality. And for the purpose of inequality, we graph inequalities this way on a number line. So let's say this is the number 3. I would graph x is greater than 3 as circling the 3 and shading to the right. X is greater than 3. Less than 3, I would circle the 3 and I would shade to the left. And greater than or equal to, greater than or equal to 3, I would circle the 3 and fill it in and shade to the right. And less than or equal to 3, I would fill in the circle at 3 and shade to the left. Less is left. And if it's x is not equal to 3, I would circle the 3 and I would shade both to the right and to the left. But I would circle the 3. Okay, so that's graphing inequalities. Basically, graphing and solving inequalities comes down to it's the same steps as solving any other equation. You just have to remember one simple rule. If you multiply or divide by a negative, flip the inequality symbol. Flip the less than to a greater than to a less than, a greater than or equal to a less than or equal to, or a less than or equal to a greater than or equal to. Okay? And that comes from this. If I say 2 is greater than 1, that's true. But if I multiply both sides by -1, I now flip things around, so -2 and -2 and -1 have switched places. Look at it on the number line. Here's 0, here's -1, here's -2, here's 1, here's 2. 2 is greater than 1 because 2 is farther to the right. But when we switch them to negative, -2 is less than -1 because it is to the left. We have this flipping effect going on over the point 0. Okay, so that's the exception to the rule. Other than that, it's the same as solving any other equation. And let's go ahead and do a few examples. All right, here we go. Here we go. Here we go. All right, so we peel the onion, right? Work from the outside in. We're going to get rid of the +5 because it's further from the x. Opposite of +5 is -5. Do it to both sides. Do the same thing to both sides, right? Because we're using the equation principle, which is balance. Anything you do to one side, you do to the other, of the inequality symbol in this case. Okay, and we get 2x greater than or equal to -6. Opposite of times 2 is divide 2. Divide both sides by 2. Did I multiply or divide by a negative? I did not. It's what I'm dividing by that determines whether I flip the inequality symbol. I'm dividing by +2. Doesn't matter that I'm dividing into a -6. Okay, and so I end up with x greater than or equal to -3. Okay, if I had to graph that on a number line, I would graph 0, 1, 2, 3, -3. Greater than or equal to, I fill in the circle and I shade to the right. Okay, So that's solving and graphing the solution set. The solution set looks like x such that x is greater than or equal to -3. Okay. Another example. Okay. This one we're going to use some multiplication by a negative because we have a negative under the in the 4 next to the x. So peel the onion. Opposite of +2 is -2. Do the same thing to both sides of the inequality symbol. Keep it balanced. Do the same thing to both sides. So 4 minus 2 is 2. So we have negative x divide 4 is less than or equal to 2. Okay, now to get rid of the divide -4. Now there's negative. The negative can be thought of as being in front of the x or the bar, fraction bar, or the 4. I think of putting it in front of the 4. Now you can't put it in two places because a negative is a positive, right? But you can think of putting it in front of the x, in front of the 4, or in front of the whole fraction. For the sake of imagining here, I'm going to put it in front of the 4. The opposite of divide -4 is times -4. So multiply both sides by -4. We end up with -4 divide -4 is 1. 1 times x is x. And we just multiplied by a negative, so we flip the inequality symbol. Okay, we flip the inequality symbol because remember that thing happens where it flips over the 0 on the number line and order changes, order reverses. -8. Okay, so the solution set looks like x such that x is greater than or equal to -8. If we were asked to graph it, here's -8, here's -9, here's -7. We would circle the 8 and shade to the right, not filling in the circle. Okay. And final example here, we've got to do one with a few more steps, some distributing and regrouping. Okay. Remembering the steps here. Okay, first I'm going to distribute the 2. Okay. And we're going to get 2x plus 14 plus 5x and 9x minus 6, still less than or equal to. A little regrouping, combining like terms. 2x's and 5x's are 7x's. So 7x and 14 is less than or equal to 9x minus 6. Now here you have a choice. You could subtract 9x from both sides and end up with a negative, in which case you got to remember that if you multiply or divide by a negative, you flip the inequality symbol. I'm going to follow the rule, I like to keep it positive. So I'm going to subtract 7x from both sides because 7x is less than 9x. Result in a positive solution, minus 7x from both sides. And I'm going to get rid of the 7x by subtracting 7x, but I'm also going to get rid of the minus 6 by adding 6 to both sides. Kind of combining two steps in one. Okay. And we get 7x minus 7x is nothing. 14 and 6 is 20. 20 is less than or equal to 9x take away 7x is 2x. Okay, now divide by 2. I'm dividing by a positive, so I do not flip the inequality symbol. X is less than, well, let me talk about how to read this. This reads 10 is less than or equal to x, but it also reads x is greater than or equal to 10. And this is the other rule here. When you flip around the inequality, if you switch sides, you have to flip the inequality symbol as well. So this reads x is greater than or equal to 10. So we write the solution set x such that x is greater than or equal to 10. We graph it as follows. 10, here's 9, here's 11. We would circle and fill in the 10 and shade to the right. Okay, so that's really the kind of a summary of the idea of solving inequalities.